Get the recordings. Okay. So this evening, I did not have a specific victim to come and talk to us, but I thought I would, let's see, let's get sharing set up. We want to share sound, that screen. Okay, hopefully you're seeing my browser. And I wanted to share, I've been talking about remote stations and low band receive antennas and that sort of thing. And I think I showed this picture at one of the meetings. It's a photograph of, or a piece of a video. I took a snapshot of it, of Steve, Victor Echo 6, Whiskey Zulu, and about using the super low band, one probably 500 hertz to 3 kilohertz, perhaps, listening for airplanes during World War I. But he's a low band guy, and so I thought he built a remote station, and he gave a very nice talk to another group that was recorded. And so I thought I would play that and maybe inject some comments here and there. So for those, some of the acronyms that he used, he talks about HAFTA, HFTA, which stands for High Frequency Terrain Analysis. And so he did some modeling. He'll talk about, basic overview is he'll talk about why he picked where he did. So what location he purchased and why he chose that location. He'll talk about getting power to the site, preparing the site so that you can put antennas and control station and so forth, and building it out so you can remote it. And then he'll talk a little bit about the various antennas that he did set up and why, and improvements he made to the setup. So I thought it was a nice overview for anybody that's interested in building a remote station. And so let's get this started. And hopefully I've shared the sound, so hopefully it should come through. Good.
Thanks a lot, Ron, and also Tony for the introduction, and hi everyone. Thanks for inviting me. It's great to be here and contribute to your conference. You know, I must say that Ron, Tony, and Rob, you guys have done a great job getting this all organized, and you guys at COO have an impressive organization. It's quite amazing. Quite amazing, actually. I've got 8 cameras at my remote station, and this is a screenshot from the camera at the top of the main tower. And this is a view looking northwest toward Japan. And in fact, if you look closely, you can see the 80 and 40 meter Yagi elements. Okay, let's talk about my move from my typical suburban lot in Calgary, which is shown here, to the remote. By the way, the slide has moved. We're good?
Yes, it has. Yes.
All right, let's keep going. So I operated from this QTH for 17 years, and I always felt relatively competitive on the low bands. In fact, on 80 meters, it actually seemed I could keep up with some of the big boys from the West Coast. Working the long path into Europe, my little baby 2-element 80 meter Yagi could keep up. And on 160, during the last solar minimum, I was, working about 100 DXCC each winter. And I talked to a lot of the local guys here that also were active, and often they weren't even able to hear the DX that I was working. So, the reason I'm bringing this up is something was going on, and my conclusion was that my home is on what's called Broadcast Hill. I mean, it's the highest point in the city. And I did some HAFTA analysis and confirmed that, in fact, being on this hill was indeed giving me a bump. So therefore, the number one focus for the remote was to find a hill that provided enhanced takeoff angles. I mean, all potential locations were evaluated with HAFTA. Of course, I wanted a rural, low noise setting, and I needed room for RX antennas. So I used some topo maps and Google Earth to help with the search, and eventually found two sites. One was an abandoned 1960s microwave site near a town called Bergen, but that deal fell through. And I ended up finding this piece of land, which is about 100 kilometers north of my QTH. A one-way trip takes about an hour and a half. I can go either the long way up the main highway or what's called Cowboy Trail. So I figured, this would have been manageable as far as the drive goes. This map includes some topographic contours. Hopefully you can see them there, and shows this really unlikely hill in the middle of the prairies. I mean, it's a bump in the prairies. The 10-acre parcel that was for sale is shown, outlined in this yellow box. And the luck was, it was actually for sale. It was all treed. Zoom in here. So it was all treed, 100% treed, and completely undeveloped raw land. And it had sat on the market for quite a long time. And so the sellers were somewhat motivated, and I think I got a pretty good deal, to be honest with you. I think that perhaps potential buyers were a little bit put off by the need to build a road and the fact that it hadn't been developed. What I did need was power. And indeed, there was power along the main county road, and I needed internet. Well, it turns out that I share this hill with a bunch of comm towers, which I've annotated here. The one here to the east actually is one of my internet service providers. And then this tower, actually the closest tower, also had a WiMAX provider on it. This microwave tower here to the west, it's actually a 500-foot microwave tower. So here's a view of the hill taken from about Google Earth, Street View. It's about 7 kilometers to the southwest. I don't know if you guys know it, but in Google Earth, you can draw a line through anything and plot an elevation profile. This is the profile looking to Oceania and to Europe with the remote location on the top of this little hill. And here's the terrain profile to Japan and South America. So I'm not going to show the details because there's just not enough time for this in terms of the terrain analysis, but I did do HAFTA analysis on this. And again, I was motivated because of my experience in the city that I knew that being on a hill was good. But this just shows the what I was dealing with about 2,500 feet out from the crest of the hill. I'm about 150 to 300 feet above the surrounding terrain, and out at 9,000 feet, I'm still 200 to 400 feet above the surrounding terrain. So let me give you a quick tour of how I developed the remote. This is kind of the preliminary development plan. I mean, basically, I needed to blast a road in here and clear the trees to house the radio equipment, and I also wanted a place for a 9-circle receive array. Here's as we were starting to build the road, what I decided to do was harvest the trees rather than just take them down and burn them. I had a feller buncher come in and a delimber. I don't know if you've ever seen a delimber work, but it's really a cool thing. It turns out that these trees are really old growth. I don't think it's ever been cleared, and a lot of the trees were kind of rotten. So I didn't really achieve the cost recovery I had hoped, but I mean, I almost broke even for the tree clearing. This is a view of the approach. It comes right off of the rather east-west county road, which is paved. So it's it's a nice approach for getting in. This is a view of the steel high hog fence that I installed. This is my first point of entry barrier to prevent any ingress, anyone that might want to come into the remote. This is at the top of the hill as we were just beginning to, finish up clearing the trees. We burned all the unharvested trees and buried some of the stumps. And here's a view after we removed the topsoil and replaced it with clay. As you'll see later, this eventually gets covered in gravel. I brought in overhead power from the main road, as I said. The cost wasn't that bad. There's only 4 poles to the road, but maybe as you guys all know, this ends up ultimately being amortized on my electrical bill. In fact, I mean, my delivery charge is more than my actual electrical use charge. I decided to house the equipment in a construction or oil field work personnel trailer. I considered a CCAN, but I kind of felt this would be a better solution and perhaps easier to customize. And in fact, this is that trailer. It's a 10-foot by 24-foot box, and I decided to wall off the 7 feet at the one end and install or put just a regular rack in the middle for the equipment so that I could, have access and walk around it. This is a view of the trailer before I built the room in the back. You can see there is air conditioning in it, and that is the room that the radio is housed in. Here on the left, I'm just framing in the wall. I used a steel outside door because it's insulated and insulated this wall as well. Reason being that as I say, I usually just keep this one end of the shack warm during the winter and cool in the winter. On the right is the finished product, and this end I'm standing in is kind of my workroom. It has my tools and my workbench. In the radio room, I built a shelf to house the PCs and the monitors. Here is the main the equipment rack. On the top is kind of what I would call my power distribution and switching. I'll talk about that in a little bit. This middle rack is sort of my LAN stuff, the K3, the Station Master switching, my rotor controller, Power Master, and then the lowest shelf that you can see, there's the Flex radio and the ACOM 2000A amplifier. Out of sight on the bottom rack is another amplifier and the PCs. Here's a view around the back of the rack, so I can walk around here and deal with the mess of wires. This panel here is my entry point. It's a solid copper entry panel, which is integrated into the ground radial system and the DC ground. Every single wire is either MOV, gas discharge tube protected, or lightning arresters on the coax. I installed a 6-foot chain link fence with 2 10-foot gates. I've also included some warning signs, like high RF voltages on the tower structures, don't enter or you will die kind of thing, just to try and prevent anyone from thinking they might want to climb the tower. The entire fenced in area is covered with radials. Here's a view of yanking the US tower crank up out of the home QTH. I hired a 50-ton crane with a 150-foot stick with a jib out to get it over the top of the house. To the right, you can see I'm loading it on a 40-foot trailer with a truck, with a picker truck, so that it can be offloaded at the remote. You probably can't see it, but on that trailer is also a prefabbed rebar cage. For the US Tower base, I gave the plans to a rebar fabricator, and they made it for me, and then these guys picked it up rather than trying to do my own rebar work. And in fact, here we are at the remote. This is the US Tower base. I followed their you know, plans for the base. To be honest with you, I think it's overkill. I mean, this hole's 9 feet deep and 6 feet square. I've got the rebar cage in there. Um, Boy, my backhoe guy did a tremendous job. I mean, these sides of this hole is almost perfectly straight. But anyway, super easy to fill. I mean, you know, unlike a backyard job, I mean, we just back up the cement truck and fill her up and run the vibrator, and we are good to go. Here I am raising the US tower. I happen to already own and have this raising fixture from a US tower. It's an accessory. And I was able to do this all myself. I used my man lift with some slings and some come-alongs, and I was, you know, able to get the tower bolted onto um, the tower wings, and then this with the raising fixture, I just crank it up to vertical. On the right, you can see the tower at cranked up at full height with no antennas on it. This is a powered, motorized crank up, and I have it configured so I can raise and lower the tower remotely from Calgary, and I also have a wind gauge, which over a certain wind speed, it will automatically retract. Here is this is why I love my man lift. I can work on anything on this tower when it's cranked down to 24 feet. Honestly, I mean, what a pleasure to do antenna work. You know, I can even go out and work on the element tips if I want. This, by the way, the Yagis weren't fully assembled yet, but I bought this man lift used from Ritchie Brothers auction. I had a grader level the pad, the area, which is 100, by the way, the fenced in area is 140 feet square. I might have forgotten to mention that. This was to prep for the ground radials. And I shunt feed the tower for 160 meters. And so this is the ground system for that. I have 3/8 inch tubing, copper tubing all the way around the base, onto which the radials are soldered. And then 2-inch wide copper straps are then in 4 places bonded to the tower. There's 100 radials, and as they say, they all go outwards and are actually electrically bonded to the chain link fence. Let's have a drink here. Hopefully I'm not going too fast, but I'm trying to, we had a bit of a delay there with me, so I don't want to go over time here. This is the Yagis that I have on the tower. At the bottom, on the right here is a zoom in. On the bottom is the 2-element 80 and 40 meter Yagi. This is the same Yagi I had at the city location for the low bands, and above that is an Opti beam, the OB95. I don't really use that very much. It's pretty rare to find me above 40 meters. I shunt feed the tower for 160 meters. You may or may not be able to see the shunt wire to the right of the tower. But here's the thing, after my second winter season on 160 meters, I started to realize that I kind of like had more RX and less TX, especially into Europe with the guys operating in a high noise environment. You know, I could kind of hear them, but they weren't hearing me. So I needed some TX gain. I decided on a 2-element parasitic array using the existing shunt-fed tower as the driver. I considered a 3-element parasitic like K3LR and others use. But in the end, I decided that the added 1 dB of gain really wasn't worth the effort to try and squeeze that other element onto my small little area here. Having said that, the 3-element design has significantly better front to back. I mean, it's spectacular. This 2-element is pretty crappy, but for the front to back, but I don't use my transmit antennas anyway on receive, so I kind of figured, you know, that I can live with that. The array is made from these parasitic elements, and they're made from 4-inch irrigation tubing, and they're 75 feet high, and loaded with 50-foot long top loading wires to bring them to resonance. And so at any one time, only one element will be active while the other is floating and therefore invisible. And so, for example, if we look at the southwest parasitic, when tuned as a director, it would be beaming to Oceania. And then with some inductance included and tuned as a reflector, it's beaming to Europe. And then, of course, conversely, the southeast element would be beaming to either Japan or South America. I modeled and designed the array using Fornec2 as a picture of the model there on the left. I was able to raise these 75-foot elements all by myself using my man lift as an aerial support. I don't know if you can see what's going on here, but I attached a pulley to the top of the man basket, and then the pull rope through the pulley goes down to basically a boat winch bolted to the main tilt support. And the thing is, these irrigation tubing elements aren't heavy. I mean, this whole element barely weighs 100 pounds, and then once the element was vertical, it's guyed in 3 places and at 3 levels using Dacron rope. Here's the element base for those who might be interested. First of all, there's a 4x4 post cemented into the ground, and then basically a 2x6 bracket with a 1/2-inch bolt kind of makes up the hinge point, if you kind of see what's going on here. The element split and is insulated from the ground. The main part of the element using a 4-inch PVC external coupler, right? And then I just drilled a hole to gain electrical access to the main element. I just want to spend a little bit of time here because I think this might be something some of you guys might be interested in, because I really like these elements. This 4-inch irrigation tubing comes in 40-foot lengths. I purchased it new from an irrigation supply house. And so obviously the 75-foot elements are, made by a 40-foot piece spliced with a 35-foot piece. And you can sort of in the inset here perhaps see my approach to making the splice. I essentially slit a 2-foot length long piece down the middle with my aluminum blade, and then compressed it with worm gear clamps, and then that splice is an internal coupler, okay? And then I just remove the hose clamps and then complete the splice with blind rivets or pop rivets. This tubing's most irrigation tubing is 0.058, but in my case, I purchased this stuff called torque tube, and I think it's the stuff used for the mechanical construction of those big irrigation systems, like like the pivots. My stuff is that stuff. It's 0.077 wall, and it's pretty solid. And in fact, to the left, you can to the right rather, you can see me. It's a picture of me cranking it up. You can see, for one thing, that joint held up pretty well, and there's a decent amount of flex, but it's hanging in there. One thing I would caution you, though, of course, is this stuff is not made to be structural. It's got a seam in it. It's not seamless tubing. It's been roll formed, and I don't know if I'd want to use it for horizontal elements, but it's been holding up very well in the vertical situation. I encourage you guys to consider using irrigation tubing for vertical elements. I think it's perhaps cheaper and maybe easier to install in using tower sections. For sure, I think an 80-meter foursquare would be like really easy. I mean, I don't know. I think you could even like hand bomb it up, like Iwo Jima style, like just like hand lift it up with a couple guys. I actually have plans to raise 120-foot vertical using 6-inch, what they call suction tube. It's 0.083 wall stuff using the falling derrick method. And one last thing regarding this array, I really warn you that I've learned from experience that parasitic vertical arrays are very sensitive to ground losses at the parasitic element. I mean, both the gain and front to back can diminish really quick if the element current is less than ideal. I mean, a no compromise radial system is essential. I mean, you model this, it's easy to do, even in a Minineck engine. You introduce some R or some, you just put some series resistance in and watch the front to back crash. Here's a view of my expanded radial system. And, adding radials is not glamorous or visibly rewarding experience, but seriously, covering your landscape with copper really, really can pay off. It's a bit of a challenge for me. I got to be on my hands and knees in the forest here, running wires under deadfall, but it's definitely worth it. I think I'm going to rename this hill Copper Hill. That's almost 3 acres of radials. All right, let's talk about my receive antennas. I own only the 10 acres of land shown here. You can see my road in my main area, but I don't own the surrounding land, but my neighbor was very friendly guy and has allowed me to run wires out into the surrounding forest. I have a total of 15 beverages. They range from 750 to 1,000 feet long. And I cover 9 directions with those. I have 6 broadside phased pairs with 400-foot interwire spacing and 3 single wires. I also have a 9 circle array. I lost my mouse here. I want to talk about my experience with broadside phased pairs because I've used and experimented a lot with on echelon end fire staggered pairs quite a bit, but until I moved out to the remote, I never had room for broadside pairs, and I got to tell you, these antennas are amazing. Had to have a drink there. So this is a view out of my 4NEC2 model of a single beverage wire. It's got an RDF of around 11.7. Now, I'm assuming you guys all know about RDF, or at least have heard about it, but a better RDF, received directivity factor, really truly does translate into a better copy. So what if we take 2 of these wires, 2 beverage wires, and space them anywhere from 1/2 to 3/4 of a wavelength apart, and we combine them. We'll just use equal length feed lines to a central point, combining them in phase with a 0-degree hybrid combiner or a magic T. So if we do that, here's a 4NEC2 output of a broadside pair spaced 200 feet apart. Okay, now I've overlaid that with the single wire, a beverage in blue, and so we've gained 3 dB of forward gain. Well, of course we have, because we've now got 2 wires in phase. But you'll notice the RDF indeed has improved. We're now up to 13.1 instead of 11 dB. But if we space these 400 feet apart, we increase the RDF to 14 dB. But it's important to notice here that our forward 3 dB half power beam width is really narrowed. Okay, I mean, we've narrowed it out, and that's why the RDF is improving. And in fact, if we space these now 500 feet apart, then we're up to 15 dB of RDF, which is really a spectacular antenna. Now, one question is, do these things really work? And all I can say is an astounding yes. I mean, they really and truly work. And now I've designed the feed box for all of my phased pairs to include some relays so that I can instantly, I can switch between any one individual wire or have them phased. And so therefore, the point is I can do A-B comparisons between a single wire or the phased pair. And many times with doing these testings, that extra 2 or 3 dB of RDF has absolutely made the copy, the difference between copy or no copy. Like I'm barely hearing them on the single wire, but the pair pops them out of the noise. All right, so the thing is though, there can be compromises with these antennas. Because of the narrow forward beam width. And in fact, in this diagram, what I'm showing here, at first I had a pair to the north and a pair to the classic European 45-degree azimuth direction, okay? And last winter, I started to notice that I might have a problem here because Northern Europe and like even the OHs in Russia seem to almost be better on my north pair than on the Europe pair. And um, something had to be going on. So I plotted these together. And of course, you already can see what the problem is. I mean, I'm 4 dB down in this notch between these two. And at first you might say, well, well, whatever. But here's the whatever. This is, a great circle plot from my QTH and V6 for that exact notch. And it turns out there's some juicy stuff in here. I mean, I've got Norway and Sweden and Finland and Poland and, Latvia, Lithuania, Romania, most of European Russia. So I reckoned I needed to add another pair. And in fact, that is what I did. I added a pair to 21 degrees to fill in that notch. And the point here is this winter, this pair has really added to my RX. I mean, switching between at times shows that the LYs, SMs, the YLs, the OHs, can be really, really solid on that 21-degree pair. But if I switch back to the regular European pair, in some cases, they're almost gone. So, I mean, it really, truly has made the difference. And in fact, conversely, I mean, the Germans and the French and Italians and in the UK are always better on the 45-degree pair. And so anyway, for contesting, I mean, I don't know, what does this mean? Maybe it could be a problem, right? I mean, in the sense that, it's just going to be a whole lot of switching. But the one thing is, there's a price for everything. I mean, there's no free lunch. I mean,
So I wanted to, after this little bit of discussion you did, I wanted to back up and show you where those antennas are on his, back up here to this image. So the antennas he's talking about are these beverages. So this blue wires, that's one beverage that's pointing north, broadband, broadside to each other. So it's 918 feet long and 400 feet apart. And then he put in another one here, this orange one to the northeast at 45 degrees. And then he added the white one at 21 degrees to fill in that gap so he can cover all of Europe, from the northern part of Europe all the way to the southern part. And so that's what he was talking about when he said he added another antenna. But he also has the green pair to the northwest to go to Japan and China and so forth. And then he has a purple pair for going west. And then he has some singles. So he's got a single going to the east for like South Africa, Namibia, and Angola. And then one to the southeast to get down to like South America and Argentina and Falkland Islands and so forth. And then due south, pretty much gets you the Chile and some of the islands in the South Pacific. And then he has the yellow pair, which is out to the southwest for Australia, New Zealand, and New Guinea, and Papua New Guinea, and all the a little bit further north in the South Pacific. But for all those little islands out there, Midway and so forth. But this is what he was talking about with filling in the gaps where there's lots of amateurs, and he's a contester, so he wants to make lots of contacts during the contest, and there's lots of people in Europe. So let me go back to where we left off with him here. Somewhere right about here, I think.
Contesting, I mean, I don't know, what does this mean? Maybe it could be a problem, right? I mean, in the sense that, it's just going to be a whole lot of switching. But the one thing is, there's a price for everything. I mean, there's no free lunch. I mean, an antenna with a more broad forward beam width is just won't have the same RDF, and maybe and likely will not be hearing as well. I mean, most of the time, these broadside pairs will out hear my 9 circle array. Speaking of which, moving along here, I want to talk about my 9-circle receive array, because for a lot of guys, I think this is a real meaningful option for a smaller lot. And I built this to complement the beverage system, because I am always on 160 meters using a diversity receive. That is, the beverages in one ear and the 9-circle in another. I cleared.
I just wanted to mention that he talks about the YCCC. That stands for the Yankee Clipperton Contest Club. They're out of the New England area, and they usually run many different contests as a group, and they'll move from one station to another. There's several guys up there that have multi-operator contest stations in that location or in that area. And so that's who he got the design from.
Some trees off to the west to make room for this array. And here's what it looks like in the field. It really, what it is one central vertical surrounded by 8 other verticals. But really, at any one time, there's really only 3 verticals that are active. And basically, they're in a 3-element end fire setup. The elements are 25 feet high, just aluminum whips, and they're spaced about 60 feet apart. So about 120-foot circle. There are no radials required. These are fed at a high impedance point with just a ground rod. This array was developed by John, W1FV, and marketed by the YCC Contest Club through DX Engineering, although they don't sell it anymore. And John did the modeling and sorted out the optimum phase and amplitudes on the 3 elements to develop this just excellent pattern. And in fact, here it is compared, the 9-circle in red to a single beverage wire. And you'll notice that the RDF, I mean, they're basically equal. In fact, you could argue the 9-circle is slightly better, but this doesn't really mean anything in modeling, but they're close. But really, the real benefit here is you've got this beautiful, more enhanced, let's put it that way, beam width on the front. So, that's a plus. And the way the 9-circle gets away with that is it's got really excellent control with these rearward lobes. So, I mean, if you think about it, what do you got going here with one of these? Well, this is like having 8 918-foot long, or 900-foot beverages, 8 of them, all in a 120-foot circle. So pretty effective antenna. These are the high impedance amplifiers that I designed in KiCad and built. It's an op-amp based amp, and John W1FV designed them, and they're really quite phase stable and immune to IMD. Here's one mounted at the base of the vertical. This is the combiner box that I also designed, and in this case I integrated a high impedance, a 2N5109 amp on the output to include on the board. All of these small vertical arrays require amplification. I put it in an aluminum box and put it out in the field in this, just a storage bin from the building supply. And this includes, the box as well as the delay lines are all stuffed in there. One thing I did want to talk about here, guys, is diversity receive. If you have not used diversity receive yet, you really ought to give it a try. I'm sure many of you know what it's about, but on 160 meters, I am 100% of the time always using diversity. I mean, it's never turned off. I mean, it's a simple concept, right? You go, 2 phase locked receivers that track when you're tuning, and stereo headphones, and basically you have, a different antenna in each ear. I'll usually use the 9-circle in one ear and the beverages in the other. And sometimes on 80, I'll even use the Yagi in one ear and the beverages in the other. Look, I've been using Diversity RX for at least 10 years. And okay, this is going to sound like a bold statement, okay? But most of the time, and I mean most of the time, diversity makes the difference between copy and no copy on The weak ones. Okay, now obviously, it's, you know, if it's a strong signals, it's not going to make a difference. But I'm talking on the weak ones. There's some kind of magic that happens where the gaps get filled in. Like, I mean, and it's not just like big long-term fading here. I'm talking about like even a dash somehow, like maybe with only one antenna, you wouldn't quite get that whole dash like in your head. It's I can't even explain how it happens, but there's some kind of magic. Also, for contesting, obviously it's an invaluable tool. I'm sure many of you already do this, but you know, for me, I'd be losing a ton of mults if it weren't for this. I mean, if I've got all ears on Europe, you know, if Texas is calling, right, off the back, yeah, I'm not going to hear them for sure. So I'll basically have the 9 circle will be the roving antenna, looking for other callers. I lost my mouse here. Oh, there we are. Okay, so how do I control all this mess from home? Well, as I said earlier, I've got I'm fortunate. I got 2 internet providers, and I've got accounts with both of them. It helps with redundancy and you know, and sort of you know, spreading the bandwidth a little bit. So you know, it's been great to have that option, to have 2 providers. By the way, the speed is pretty nominal. It's like a 1 megabit per second upload and only 4 megabits per second download. So by home standards, it's pretty crappy, but it's more than enough. Okay, so how do I switch things at the remote? I won't go into the details here, but basically anything that is frequency dependent is automated. Okay, I mean, my 160 meter array is band switched, and so is my 80 meter and 40 meter Yagis. I've got multiple relays to move across the band, and you know, I'm certainly can't man a mechanical switch. But I tell you what, even if I'm was at my home QTH, I'm not going to be manning a mechanical switch to move my my antenna around the band, especially in a contest. So I mean, really, any kind of mechanical band switching nowadays is kind of yesterday. Everyone should be moving this way, and I'm sure most of you do. So what about the rotors, my TX arrays and receive antennas? Well, here's how I do it. This is a view. Just hang on, I'm gonna have a drink of water. So this is the view of one of the PCs at the remote. Okay, now there's a lot of windows here, but just focus on these dials here. Okay, these are my controllers to change directions. This is a program called PST Rotator. PST Rotator. I got to tell you, I think it's one of the best ham software packages ever. It's just fabulous. But anyway, this blue dial is my main rotor. So I just click anywhere and the rotor starts. My Yagis are moving. The other 3 dials, the yellow one is for my transmit array. This is for my beverages, the green one, and to the right is my 9 circle. So I click east, I'm going east. So it's just a point and shoot method. Okay, contesting is not optimal, but it's the way it is. I can't have a mechanical switch in a remote setting. So when I click these dials, what I'm doing is activating one of these 3. This is my relay switchboard at the remote. The one at the top here where my cursor is, that drives my transmit array. This one is the 9 circle, this box, this relay board, and this one to the right of the beverages. So there are 8 relay boards. So, you know, if I click to the east relay will be activated, and so on and so forth. And so the receive antennas follow me. One other thing I'll show you, this is an 816 relay board here, and I'll go back here, and this is controlled by this GUI here, this user interface at the top. Okay, so I mean, I can turn the lights outside on, you know, on or off, and I can crank the tower up or down. And I mean, I mean, obviously you can do anything, you know, whatever you want. This is how I control things if I need to turn something on or off. By the way, in this view, that's my wind alarm there. It's connected to an anemometer, and it triggers a relay to bring the tower down if the wind gusts too much. So, okay, so here I am at home. So this is what it looks like at home. you know, the operating position. So to the right here is that very PC, but I'm logged in. I'm logged in with, in this case, I think AnyDesk. I've moved that way away from TeamViewer. I found AnyDesk to be better. But, you know, if you haven't used a remote desktop application, I mean, when I operate this remotely, it's just as though I'm sitting at the remote, and so therefore I can control everything with that PC. You can notice perhaps in the picture the K3. It's the K3 Mini. It's connected to the remote through the remote rig boxes. But that's not my radio of choice anymore. I find that I'm using the Flex. I like its ergonomics better for operating the remote, and the Flex software, the smart SDR software, is shown on the left screen. So that's how I control the radio. And over here, if you can see my cursor, that's called the Flex knob, and so that gives me the ability for tuning and RIT and things like that. So here's a zoom in on the that same PC logged in remotely, and in this case I'm using Logger 32, and there's my logging program. So I will log everything at the PC that's sitting at the remote by basically driving the PC. It's like I'm sitting at the remote, but I'm sitting at home. I'm just using that PC. And all CW is sent using this little thing here where my cursor is, called the CW machine. So all keyboard, all CW is sent via the keyboard. This is the same thing when I'm operating a contest, except it's N1MM. In other words, N1MM is not loaded at home, it's loaded at the PC at the remote, and the contest is being run from the PC at the remote. And that's why CW is saved. I mean, I don't have to worry about packet loss. It's being sent from the PC locally. So here is my traveling radio shack. I mean, this is it. This is a complete Radio Shack on my laptop. I mean, I can connect anywhere in the world, even with an LTE connection, and I have full control. Well, in fact, here is the smart SDR software driving the Flex radio, and I shrunk the window, right? So it's on half of the computer screen, and then I've logged into the control PC, and I've shrunk it on the right side. So, I mean, I can control everything. I mean, I can turn the antennas, I can switch the receive antennas, I can turn the amps on and off, and I can send my CW from the keyboard. You know, let's be honest. Yeah, you know, no CW paddle. I don't have the paddle. Okay, look, I love my paddle too, but really, it's no big deal using keyboard CW. I mean, at the end of the day, you get used to it, and you learn how to call up the keyboard, and it's you know, it's not a perfect world, but the beauty of this is I have full control. The thing is with this, and the reason I like the Flex, is because, you know, there's no need for other boxes or dongles or port forwards. I mean, I just open up the smart SDR software and my remote PC, and I have full control of everything, and I can do it anywhere, you know, at my daughter's house, or, you know, even sitting by the pool in Mexico or Hawaii. I mean, I've done it.
Steve,
Yes?
it's going over a bit.
Okay, I'm done basically. Anyway, there's me sitting in Australia, and you know, I had 56 milliseconds of delay, and I still had full control. This is me working CW on 40 meters. Okay, guys, thanks a lot for. I had a little bit more there. Thanks a lot for inviting me. I really appreciate it, and there's probably no time for questions, but look. Visit my QRZ.com page. If I have my emails there, and I have a few more information on the remote there too.
Okay, so does anybody have any questions or comments they'd like to make? No. I thought this was a really interesting discussion about putting together a remote station and all the thought process behind it and why to choose certain antennas. And he had to actually add some more so he could do more coverage of a particular area, and the thought behind that. And then building the 160-meter array using irrigation tubing. That's something I might consider. Because those are pretty big antennas, pretty tall. But that's a good thought. Torx, I actually looked up Torx aluminum tubing, and it's actually used for, if you're familiar with farming and irrigation, it's used for wheel lines. So the irrigation lines where the pipe runs through a bunch of 7-foot diameter wheels, and there's a motorized unit in the middle, uh, and it rolls the pipe, it twists the pipe. And so it's made for pretty high torque and pretty high torque. So it doesn't just twist the pipe in two. But like you said, it is rolled tubing, and so it does have a seam. And so you probably wouldn't want to use it for horizontal elements, but if you're going to put guide rope on it and use it in a vertical fashion, it probably works fantastic. Or at least he's had very good luck with it. So does anybody have any comments or questions? Everybody's on mute. Okay. Well, I appreciate everybody coming this evening, and we'll look forward to seeing everybody at next month's meeting in October. And I forget what day it is, October 24th or 25th, somewhere in that neighborhood. Fourth Thursday of the month. We'll see everybody again, and hopefully I find somebody that can come and present in person to us. I'm sorry? October 23rd. Oh, October 23rd, the fourth Thursday of the month. Yeah, so thanks everybody for coming, and we'll see you next month. Take care.
Thank you.
Bye.
Thanks, James. Bye.
Bye-bye.
Thanks, bye. Thanks, bye.
Bye-bye.